All right, so here we are, section 2.4, looking at some algebraic properties of equality. And this section is where the chapter starts to get a little difficult, so pay close attention. So, algebraic properties for equalities. We got addition property, which says if A equals B, then A plus C equals B plus C. All right, so if A and B equaled each other to begin with, then if we add the same thing to both sides, being C, then it's still the same thing. Right? Subtraction property, same idea. If A is equal to B, if I subtract C from A and C from B, then we should still end up with the same value of equal, everything being equal there. Multiplication property, if A equals B, then A times C equals B times C. Division property, if A equals B, and as long as C is not 0, because we can't divide by 0 without it becoming undefined, then A divided by C is going to equal B divided by C. Then we have the reflexive property, which for any real number A says A is equal to A. Any value is equal to itself is the reflexive property. Kind of like reflective, like a mirror, so it's equal to itself. Symmetric property, A equals B, then B equals A. So it doesn't matter which side of the equal sign they're on. If they were equal on one side, then they're equal on the other side. Transitive property, it's going to say if A is equal to B and B is equal to C, then A equals C. So if A and C are both equal to B, then they have to be equal to each other. And the substitution property, if A equals B, then A can be substituted for B in any equation or expression. Right? So if these two terms are equal to each other, then I can replace one with the other at any point, and I haven't changed the value of the equation at all. All right, so here we want to solve this equation, 3x plus 12 equals 8x minus 18. And we're going to write a reason for each step. So this is leading into something a little more difficult, so try to follow along here. So starting off with writing what they actually gave us. 3x plus 12 equals 8x minus 18. And since that's what they gave us, the reason we're going to give for that is that it was the given. And then in order to solve that, the next step, we would move the 8x over to each side. So if I subtract 8x from both sides, 3x minus 8x is going to give me negative 5x plus 12 equals negative 18. And what I did there is I subtracted the same thing from both sides. So we use the subtraction property. Of equality. And then from there we would move the 12 over to the other side by subtracting it. So negative 5x, subtract the 12 over, and we have got negative 18 minus 12, which will be negative 30. And once again we were subtracting. So the subtraction property of equality. And lastly, we would divide both sides by negative 5. Divide negative 5x by negative 5, and it's just going to give us x. Negative 30 divided by 5 will give us 6. And we were dividing, so that was the division property. All right. So then, moving on, we have another one here. 4x minus 2 times quantity 6x plus 7 equals negative 62. All right, so for this one, Start off just like the last one, rewrite what they gave us, 24x minus 2 times 6x plus 7 was negative 62. And they gave that to us, so that's the given. So then we have parentheses and a number outside the parentheses, so we're going to multiply everything in the parentheses by negative 2. And when we do that, negative 2 times 6x is going to give us negative 12x. Negative 2 times 7, negative 14, so it's negative 62. And we call that the distributive property. All right, so then when we look at the left side, we got 12x or 24x minus 12x, so we can combine those, part of combining like terms. So 24x minus 12x is going to give us 12x minus 14 equals negative 62. And we were combining like terms anytime that we do just math on one side of the equal sign. We'll just call that simplifying, right? We just simplified that side. All right, so now we move the negative 14 over, add 14 to both sides. So negative 62 plus 14 is going to be negative 48. And we were adding 14 to both sides, so that would be the addition property. Equality. And lastly, divide both sides by 12. That'll give us x equals negative 4. And dividing both sides by negative 12 is the division property. All right, so now moving on. Next example says a child's dose C for a medicine with an adult dose of 500 milligrams can be found by using the child's age A in years in the formula, where A equals 24 over 500 times C minus 1. All right, so solve the formula for C, write a reason for each step, and then use the result to find the child's dosage for an 8-year-old. All right, so for step A, we got A equals 24 over 500 times C minus 1. I'm going to actually work through this one first, and then I'll go back and write it neatly with all the steps labeled with their reasons. So, first thing we would do, add 1 to both sides. So we have A plus 1 equals 24 over 500 C. And then to get C by itself, we would divide, so that's 24 over 500 times C. We would divide by it. It's the same thing as drop it, change it, flip it, so multiply by its reciprocal. 500 over 24. And 24s will cancel, the 500s will cancel, which will leave C by itself over there. We have 500 over 24 times A plus 1 equals C. So now I'm going to just redo that without showing all this work. Make it nice and neat here. A equals 24 over 500 C minus 1, which was given to us. Then we added 1 to both sides, ended up with A plus 1 equal to 24 over 500 of C. And and we were adding to both sides, so that was the addition property. Of equality. And then we multiplied both sides by 500 over 24, which gave us 500 over 24 times a plus 1 equal to c. You would also be justified if you called that the division property of equality, because we were multiplying by the reciprocal. So, and then if you wanted to, just to make it look a little bit prettier, we could say C is equal to 500 over 24 times a plus 1. And on that one, we are just switching sides. And so anytime that we switch sides, that is called the symmetric property. And you could have finished without putting that on there. I just like to have the variable on the left side if I can. All right, so then there's a B portion to this, which says use the result to find the child's dosage for an 8-year-old. So for B, we're saying the age, A, is equal to 8. So if we plug that into the equation, C equals 500 over 24 times 8 plus 1. And so C equals 500 over 24 times 9. And when we multiply that out, 4,500 over 24, we divide it out, it's going to be 187.5 milligrams. All right, so moving on. Properties of equality. So the properties of equality, the reflexive, symmetric, and transitive properties that we learned just a second ago, those can apply when we're talking about segment lengths or angle measures. All right, so reflexive property for any segment AB, the length of AB equals the length of AB. Some segment's going to equal itself. Or angle A, the measure of angle A equals the measure of angle A. Any angle is going to equal itself. Then symmetric property, if length of AB equals length of CD, then the length of CD equals length of AB. Or with the angle, measure of angle A equals measure of angle B, then measure of angle B equals the measure of angle A. Doesn't matter which side of the equal sign they're on, if they were equal on one side or equal on the other. And then the transitive property, if the length of AB equals length of CD and length of CD equals length of EF, then length of AB is equal to the length of EF, right? AB and EF are both equal to CD, then they got to be equal to each other. Same thing with the angles. Measure of angle A equals measure of angle B, measure of angle B equals measure of angle C. Since A and C were both equal to B, they got to be equal to each other. Transitive property. All right, so now this is where things start getting difficult. We're going to take the idea that we used when we were solving the problems just a little while ago, giving a step and a reason, and we're going to take the information they're giving us here, that the length of AC is equal to the length of BD, and we want to verify that the length of AB is going to equal the length of CD. So we want to prove that this little part right here is the same length as this little part right here. AB and CD are the same, based on the fact that AC and BD are equal to each other in length. So first thing we're going to do is start with the information that they gave us, which is that AC equals BD. Right? The verify part, they didn't give it to us. That's what we're trying to show is true. So this is the only part that's given to us. AC equals BD, and that is given. Now, so we are looking at A to C and B to D. And those two segments kind of overlap, and they overlap from B to C. So each one of them is the length of BC plus another length, right? AB over here and CD over here. But they both have BC in them. And we want to talk about BC, so we're going to bring that into the list here by saying that BC is going to equal BC, equals itself. And that is based on the reflexive property. All right, so now if BC is equal to itself, then this is kind of like if we look back here at our properties of algebra, like the addition or subtraction property. If two things equal each other, then I can add the same thing to both sides or subtract the same thing from both sides, and I still maintain my equality. So BC is the same. AC and BD are two different things, but we know that if I take AC and I take BD and I subtract the length of BC from both of those, then they're still going to be equal based on the subtraction property of equality. So if I take AC, subtract BC from it, that's going to equal BD subtracting BC. So we're combining these two steps right here, taking the BC's away from AC and BD. And when we subtract the same thing from both sides, because we're subtracting BC from both sides, that is the subtraction property. Equality. Now, we want to, when we look at this, just looking at it, you should be able to see if I take BC away from AC, what I have left is AB. And if I take BC away from BD, what I have left is CD, which is what we're trying to get to prove or equal at the end. However, we have to explain that that's the case, that AC is made up of two different parts and BD is made up of two different parts. So we're going to say, basically define AC. AC is equal to AB plus BC. And that is the segment addition property. I mean, not property, postulate, sorry. One of those postulates we learned in chapter 1, which says that a bigger segment can be made up of two smaller segments added together. And then also, we want to define what BD is. Same process. BD is CD plus BC, which is also the segment addition postulate. All right, and so then if I take each one of these, if I subtract BC from both sides, then I'm going to end up with two new rules. If I take BC from both sides on the AC equals AB plus BC, then I end up with AC minus BC is equal to AB. And also if I do the same thing with the BD equals CD plus BC, I get BD minus BC is equal to CD. And all I did was subtract on both sides, so that's a subtraction property. Equality. And then, since AB is the same thing as AC minus BC, then I can take AB and replace it right there, where AC minus BC equals BD minus BC. And likewise, I can take CD, since it's equal to BD minus BC, and set it in right there on that side of the equation. So I can put both of those in to a new equation that's going to say that AB equals CD. And what we were doing is substituting, so that was the substitution property. Alright, so that completes it. We have verified that AB equals CD. And it took us 1, 2, 3, 4, 5, 6, 7 steps to do that. Now, I know that you're probably looking at this thinking, oh my goodness, that is ridiculous. And these are a little complicated, but after time, if you do enough of them and pay attention, they'll start to make sense. But I totally understand if this did not make any sense to you this first time you've seen anything like it. All right, so now we're going to move on and do one that includes numbers. And usually when you do one with numbers, it makes a little bit more sense. All right, so a baseball diamond is shown below. So we have a diamond here. The pitcher's mound is at angle 3. Use the information to find the measure of angle 4. So, all right. So, it does give us a lot of extra information here. All right, so the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Measure of angle 1 plus the measure of angle 2 equals 93 degrees, and the measure of angle 3 plus the measure of angle 4 equals 180 degrees. And so whenever they give us multiple pieces of information, we go ahead and put them in there. We usually start with one and then see where we can go with that piece of information. So the first thing they gave us is the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. And that was a piece of information that was given to us. All right, so we got all this information and we're trying to find the measure of angle 4 ultimately. So we know 3 plus 4 is equal to 180, and 1 plus 2 is 93. So if I take this 1 plus 2 being 93 and I insert it into this equation here, I can replace 93 degrees instead of angle 1 plus measure of angle 2. So I'm going to bring that into the equation. Measure of angle 1 plus the measure of angle 2 equals 93 degrees. That was also given. So now I'm going to take measure of angle 2, or measure of angle 1 plus measure of angle 2 here, and replace it with 93 degrees since they're equal. So 93 degrees plus the measure of angle 3 equals 180 degrees. And we were substituting there. All right, so then we've got 93 plus measure of angle 3 equals 180. So we can use this equation to figure out what the measure of angle 3 is. If we subtract 93 from both sides, we end up with the measure of angle 3 equals 87 degrees. And we subtracted to find that. Subtraction property of equality. And then we've kind of worked through everything we could do with that bit of information, but they did give us another piece of information, so we're going to bring that in at this point. So the measure of angle 3 plus the measure of angle 4 equals 180 degrees, which that was also given to us, so that's given. Now, since we know what the measure of angle 3 is equal to from here, we can replace this measure of angle 3 with 87 degrees plus the measure of angle 4 equals 180 degrees, which that was substitution again. And then we can subtract 87 from both sides, and we're going to find that the measure of angle 4 is equal to 93 degrees. And that was subtraction property. Alright, so like I said, it probably makes more sense when you see the numbers and you can see the math working one step to the next. A little more difficult than the last one with no numbers in there. But don't worry, we'll get lots of practice on these, and you may all be experts by the time it's all over. So that completes section 2.4.